Hi everyone, my name is Duygu. Today we will make a presentation about stability analysis and the controller design. It will take about 8 minutes. It's our contents. We will explain our project, its design and analysis. These are the members of our teams, 4 members in our project, and you can see their responsibilities. Before starting the project, we determine the design concept generation method, and these are goal setting, requirement identification, and etc. As you know, table and efficient operation converters is a challenging task because of time delays. So in order to analyze the time delay and design an appropriate control, we choose a buck converter that can make good observation. We identify the needs such as desired output, error value, and stability. We researched markets and engineering requirements and determined all requirements, as you can see in the page. Economic and manufacturability was of our most important constraints. And finally, we determined the standards and we designed acceptable projects according to these standards. In the level 0 design, we summarize the functioning of the systems, its main functional components, and the level 1, we have determined appropriate systems according to functions. The buck converters was chosen as a time delay DC-DC converter. For this purpose, we method of exponential elimination appropriating in the characteristic equation of the systems was adopted. We have made a benchmark for using the appropriate controller. We decided to use PI because it's widely used in the industry, it's economical, and its parameter can be easily adjusted.
Hello, I am Buket. The block diagram shows the main modus of the system. Due to measurement and communication delays within the system, a processing delay block has been included. As described in the module explanations, the buck converter reduced the input voltage from 12 to 5 voltage. The PI controller processes voltage error. The processing delay block simulates the delay occurring in the feedback signal. The exponential elimination method was used. Our project methodology consists of 3 main steps. First one, theoretical calculation, simulation verification, and last one is experimental verification. In the theoretical calculation, the characteristic equation of the time delay converter is given. The objective is to determine delay margin for system stability. Here, the component values of the converter system are presented. Equation 1 represents the transfer function of converter. Equation 2 represents the transfer function of PI controller. Next, the exponential elimination method was used to derive the characteristic polynomials of the system. As a result of the process, a sixth-degree equation was obtained. The real roots of this equation were found, and the time delay value was calculated based on specific KP gain parameters. The time delay value obtained from the theoretical calculation is 1384 microseconds. This value was verified in MATLAB Simulink, and these results show that the system remains stable. The system flowchart implemented in the MATLAB Simulink is shown here. In the Plex application, both the converter and microcontroller system were modeled with the processing delay block.
Hello, I'm Aybüke. Now let's look at the output voltage in simulation section. Using the exponential term elimination approach, the delay margin was theoretically calculated as 1384 microsecond and validated via Simulink and Plex simulation. As you can see in the first graph, when the delay is equal to 0, that's the under ideal conditions, the output voltage reaches 5 volt without any extra oscillations. When the delay time is 1350 microsecond, the system output tends towards the 5 volt reference value, but some oscillations is observed initially. In this case, the system is still stable, but is approaching stability at the limits. When the delay is 1384 microsecond, it is the points where the system reaches the marginal stability limit. During this period, the output voltage oscillates continuously around the 5 volt and no damping is observed. At the 1500 microseconds, the system becomes unstable and the oscillations with increasing amplitude were observed at the output. When we look at the verification results section, the stability of the system decreases as the delay time increases. While the system was stable 1200 and 1350 microsecond, borderline stability was observed at 1384 microsecond. At 1500 microsecond, it was determined that the oscillation grew and the system became unstable. On this page, we choose 1200 microsecond as the delay time to test it experimentally. Then we tested it both Plex simulation and the prototype circuit. Since it is the stable region, we see some oscillation at the beginning, but we reach 5 volts. This page shows the PCB design of the project created using Altium Designer. The left image shows the 3D model with component placement, and the right image shows only the layout.
Hello, I'm Ezgi. I will briefly present the cost analysis of our project. Our total fixed cost is 3,600 approximately Turkish liras, including PCB design and microcontroller. The average variable cost per unit is 230 Turkish liras approximately. With a unit sales price of 2,000 Turkish liras, the break-even point is calculated as 2.07 units, meaning the project becomes profitable after only 3 sales. To commercialize the design, we plan to establish step vault innovation, aiming to offer cost-effective and customizable solutions for the local market in competition with global companies like Analog Devices and Texas Instruments. We organized our project timeline in phases from design and simulation to implementation and testing, ensuring efficient progress tracking and team coordination. We identified possible technical and financial risk and developed alternative plans to minimize delays and ensure the continuity of the project. In a conclusion, in control system, time delays can cause stability issues. In this project, we addressed this through theoretical simulation and experimental methods. With the exponential term elimination method, we calculated delay margin of 1,318 microsecond. Experimental result closely matched simulation, confirming the controllable strategy effectiveness. The successfully tested prototype provide our system to be energy efficient, low cost and standard complaints suitable for both academic and industrial use. Thank you for listening.